is on inverse variation. If you can't tell by the name, it is very similar to direct variation. It's just that we have a different equation for working with inverse variation, and thus how we find the constant of variation. Okay, so this bottom left slide has everything we need to know about inverse variation. So it's a relationship that can be represented by a function in the form of y equals k divided by x. Okay, so inverse variation, we're taking that constant and dividing it by x. If we had direct variation like our last lesson, that constant gets multiplied by x. Okay, so when you see inverse, think divide by x. Now, if we know this equation, that y equals k divided by x, again, anything we need to do with this can be derived from this equation. And a lot of the times, or a lot of the problems, involve us identifying k or needing to pick up on how can we find k. Well, let's take this equation and let's work to get k by itself. The right side, I have k divided by x, so I can multiply both sides by x, and that gets rid of the dividing, and thus the constant k is equal to x times y. So when we have inverse variation, if we get a table of values like what we just ended the direct variation lesson with, we can check to see if that's inverse variation if we have x times y to always equal that value of k. That's what this equation is saying over here, that k is equal to y times x. And just like before, that value of k is called our constant of variation. The other note I'll make here is that for every x times y, it should always equal k if it's inverse variation. If we ever take x times y and get two different values, then it's not an inverse variation problem. So on the right here, again, it kind of shows the graphs of these. These graphs are something we do not get into in this class. These are called rational functions. I don't want to spend any time here because that's not anything we need to know for these problems. And it's a little more complex than kind of where our current algebra knowledge is at. So let's flip this over. Let's jump straight into the problem sets where they're actually almost identical to what we did with direct variation. But again, we need to read the problem and recognize what information are we given. So it says use the given information to write an inverse or an inverse variation equation and find the missing value. So when I read number 1, it tells me that y varies inversely. As soon as I see that varies inversely, I'm going to write my inverse variation equation of y equals k divided by x. I really like that being our starting point because the more we write that equation, the more likely we are to remember that. And then, using the given value of y and x, we can solve for k and then come up with our equation. So now I'm going to take y, which is 15, k, which is what we're solving for, divided by the given x value of 4, and I can get k by itself by multiplying both sides by 4. So when I multiply both sides by 4, I get that constant of variation k is equal to 4 times 15, where 4 times 15 is 60. Then my equation, and every equation we write needs to have a y and an x. It's going to involve this constant k. So the equation is y equals 60 divided by x. Once we have the equation, now we can use that equation to solve for any missing variables. Okay, so the next part of this says find y when x equals 6. So now I'm going to take this same equation, I'm going to replace the x with 6, so y equals 60 divided by 6, and after simplifying the right side and doing that division, we get y to be 10. Okay, so really not any different from the direct variation problem. It's just that with it being inverse variation, we have a different equation for that. Okay. Any questions with coming up with that equation and or finding the value of y? Okay. We're going to skip number 2 as it really is just that same process there, and you'll get practice with that with the homework. And let's jump over to number 3 as we're kind of doing the same thing. But now in number 3, we're going to have to find x, and we're going to be given y. Okay, so let's, again, start with the reading and recognition. So it says if y varies inversely, as soon as I see that varies inversely, I know that I'm working with an equation in the form of y equals k divided by x. Then I can substitute the given y value and the given x value to help me solve for k. So y is 7, x is 12, and I can solve for k by multiplying both sides by 12. I get that k equals 7 times 12, which is 84. Now that I know k, I can write the equation of this inverse variation. And that's that y equals 84 divided by x. Now that we have the equation, we can use that equation to solve for a missing variable. And this time, we're given a value for y, and we need to solve for x. So I'm going to let y be 28, and it equals 84 divided by x. The solving here is a little more complex because we're dividing by x, and that's always going to be the first thing we want to undo here. Okay, anytime we have those fractions, it just makes it a little more complex. So reading that right side, I have 84 divided by x. Well, I can undo dividing by x by multiplying both sides by x, which now brings my equation to 28 times x, or 28x, and it equals 84. And now we can get x by itself by dividing both sides by 28. Because when we see 28x, that just means 28 times x. So I need to divide by 28, divide by 28, and we get that x equals whatever 84 divided by 28 works out to be. So 84 divided by 28 is 3. And we're all done there. Okay. Any questions there? Awesome. All right. Well, we got 2 more problem sets. And again, they are very comparable to what we did with the direct variation. So if you look at the next problem set here, make sure everyone's done writing. All right. We're given a bunch of equations, and our task is going to be to find the constant of variation. Again, we want to start with, well, what do we know? We know that an inverse variation equation is in the form of y equals k divided by x. So if we can get the equation or get y by itself, we know that the numerator, okay, whatever number is being divided by x, is our constant of variation. Okay, the other thing that we can do, and this is that extra layer of recognition, is we can work to get k by itself here. So if we ever see x times y, that's going to give us the value of k. So let's take the same equation, let's multiply both sides by x, and thus k is equal to x times y. So we have kind of 2 ways to be able to pick on what our value of k is equal to. Well, number 5, if I look at this equation, that's y equals some number divided by x. Well, that is the exact equation for inverse variation, and thus 12 is our constant. K equals 12. Done. We didn't need to do anything else, right? Y was already by itself. All we needed to do was recognize that the numerator, or the number being divided by x, is that constant. Number 6, if we have that extra layer of recognition, and that x times y is equal to k, well, that's already set up here, right? That's x times y equals the number 2, and thus 2 needs to be our constant k. Now again, not all of us are going to be that quick and that good with that recognition. So let's kind of keep it consistent and get y by itself, which I can do by dividing both sides by x. That gets rid of the x's here, and I get y equals 2 divided by x. Well, there's that number being divided by x, making k equal to 2. Okay, so those first two are a little more straightforward. Now the next two, 7 and 8, does anyone recognize the type of problems here from our last unit and what we called those problems? Or maybe even the solving method we used to solve these? Yeah, cross multiplying. They're proportions, okay, and we can solve them by cross multiplying. If we ever have one fraction equal to another, I'm going to always recommend that that's be our first place to start here. Okay, so let's do the cross multiplying, and then we'll kind of see where we're at from there and game plan how we can't get y by itself and identify k. So the first thing I'm going to cross multiply is y times x, or xy, and it equals the other cross of 7 times 1. Well, 7 times 1 is just 7. So I'm going to simplify that, making this x times y equals 7. And again, those of you with a good recognition will say, hey, x times y is equal to k, and thus k has to be 7. Others of us maybe don't see that right away. And so instead, we're going to work to get y by itself, where I divide by x. And thus, I get y equals 7 divided by x. And sure enough, that value of 7 is being divided by x, and thus k equals 7. Right, and then the last one here. We definitely need to cross multiply. This one's a little more complex. Be careful with this negative here. That messed up a lot of us on the assessment portion. Remember that that negative needs to go with just the numerator, just the denominator. Okay, so I'm going to always put that with my numerator. So my first cross I'm going to do is 4 times 1, which is 4. And it's going to be equal to me doing the other cross of negative 9y times x. So we have negative 9 times y times x. And we're going to work to get y by itself. And I can do that by just dividing everything that's being multiplied to that y. I'm going to do that in 2 steps. So I'm going to first divide this by negative 9. So negative 9's go away, and I get negative 4/9 is equal to y times x. Well, there's that y times x, so I can pick up on what k is already. If I want to take it one step further and divide by x, I can do so. And I get that y equals negative 4/9 divided by x. So I wrote that really small, ran out a little space there. And thus, it's this entire fraction being divided by x. So our value of k here is the fraction of negative 4/9. Okay, so a little bit trickier with that value being a fraction. The process is still almost the exact same. All right. Got one last problem set to cover, and then we're done with semester 1 of Algebra 1. Kind of exciting, right? Even though our energy is not the best today, my energy is not the best either. That's okay. It's just the time of year. All right, here we go. So here's where these become a little bit more difficult. I'm going to give you a table, but now with this table, we don't know if this is inverse variation or direct variation. We need to decide, is it direct variation or inverse variation? Again, I'm always going to recommend that we write out what do we know. I know that for direct variation, that equation is y equals k times x. And I know that if I want to decide if a table represents direct variation, It's that value of k that I need to see, and I can see that by dividing both sides by x, and thus the constant k is equal to y divided by x. So we can check that. Let's try number 9. Let's see if it represents direct variation. So if I take y divided by x, -6 divided by -2, I get 3. Then if I take 4 and divide it by 3, ooh, that's definitely not 3. That's 1.33. Okay, so this right here tells me that it is not direct variation. And so the next thing I'm going to check, maybe it represents inverse variation. So I'm going to write down what I know about inverse variation. That's that the equation is y equals k divided by x. And again, it's helpful if I can get k by itself here, which I do by multiplying both sides by x. And thus, x times y is equal to that constant k. So now let's do the same thing. Let's see if we take x times y and do we get the same values here. So -6 times -2, that's 12. 3 times 4, that's 12. And 6 times 2, that's also 12. So because every time we take an x and a y and we multiply them and we get that same value of 12, this is going to represent inverse variation, where our constant is 12. And now we need to write the equation with its inverse variation form of y equals 12 divided by x. All right, let's do one more here. And then maybe we can quickly check number 11 if we got time. All right, so number 10. And I'm not saying check direct variation first or inverse variation first. Really, we need to check them both unless one of them works out right away. So let's just go the same order in which we checked the first time. Let's try direct variation first. So if I take y divided by x, I got -6 divided by -2. That's 3. And I've got 9 divided by 3. That's also 3. Then I have 18 divided by 6. That's also 3. Well, that worked out nice, because every time I take y divided by x, I get that constant k. Because y divided by x is k, this is direct variation. And our equation is y equals 3 times x. And we're all done. All right, the last one, let's just real quickly check it. And I can do that with a calculator since I don't have a lot of room. Be patient with me. I know we're getting close to the bell. But let's just check this one last time. So let's first check, is it direct variation? So if I take y divided by x, do I get the same number? 6 divided by -8 is -0.75. 24 divided by -2 is -12. So already, since y divided by x is giving me different values, that tells me this is not direct variation. Then, hold on. You have a homework coming as well, so don't put the binders away. Now let's check the multiplying. If I take -8 times 6, I get -48. -2 times 24, I get -48. And 12 times -4, I get -48 as well. So this means that k equals -48. Since we're getting that by multiplying x times y, this is inverse variation. Our equation is -48 divided by x. Okay. Well, that is it for semester 1 of Algebra 1.